Hi, welcome back to College Algebra. Today I'd like to talk a little bit about inverses and identities. Inverses and identities are the backbone of algebra. What they do is they allow us to always get back to where we started from. There are all kinds of different inverses and identities that we're going to learn over the semester, but we're going to start with two: the additive inverse and identity and the multiplicative inverse and identity. Let's get started and I'll show you what they're all about.
There are lots of different inverses that we'll encounter in algebra, but the first two we want to look at are the additive inverse and the multiplicative inverse. The additive inverse has an identity of 0. What this means is when we apply the additive inverse, we're trying to reach that number 0. This is easy to think of on a number line. If we begin at 0 and move forward 3 spaces, how do we get back to 0? Well, that's simple. We just move backwards 3 spaces. So 3 plus -3 equals 0. In general, we say that a plus -a equals 0 for some real number a. This is very interesting because when we have -5 and we're trying to find the inverse to -5, well, we know that that's the negative of -5, which of course is just 5. So -5 plus 5 equals 0. If I wanted to apply this, I could say we have the equation x plus 7 equals 10. And I want to solve for x. Solving for x means I isolate x. I want x on one side and everything else on the other side. That means I need to get this 7 to the other side here. To do so, I just apply the additive inverse of 7 to both sides. So x plus 7 minus 7 equals 10 minus 7. Now it's just a matter of doing the arithmetic. X plus 7 minus 7, well, that's x plus 0. So this is just simply x equals 10 minus 7, which is 3. Let's take a look at the multiplicative inverse and its identity, which is equal to 1. So with the multiplicative inverse, if we have some number a, we want to multiply a by some other number so that it equals 1. That's just simply the reciprocal of a, or 1 over a. So for example, 2 times 1/2 equals 2 over 2 equals 1. 1/3 times 3 equals 3 over 3 equals 1. How about 5/7? What can we multiply by 5/7 to equal 1? The answer is pretty easy. It's just 7/5. Let's look at the math behind that. So we have 5/7 times 7/5. This is equal to 5 times 7 is 35 on top. 7 times 5 is also 35. This equals 1. We can use the multiplicative inverse to solve for x. Say we have 3x is equal to 12. We want to isolate x. To isolate x, I need to get rid of this 3. So I'm going to apply the multiplicative inverse of 3, which is 1/3 to both sides. 3 times 1/3 is 1. All we're left with on that side is x. 12 times 1/3 is really 12 divided by 3. That equals 4. So x equals 4. An interesting multiplicative identity that is unique is the multiplicative identity for -1. What can we times by -1 to equal 1? The answer there is -1. -1 is its own inverse because -1 times -1 equals 1. So if we had something like -5/7 and we want to go to the inverse, its inverse is going to be -7/5. So let's look at solving linear equations by using inverses. Say we have the equation 3x plus 7 equals 28, and we want to solve for x, which means we want to isolate x. We want to do our additive inverse first. We look at this equation, we say, well, we want to move that 7 over first. That means that I need the additive inverse of +7. The additive inverse of +7 is going to be -7. So we add -7 to both sides. On the left-hand side, we just get 3x. On the right-hand side, we get 21. Now, we want to use the multiplicative inverse. We have 3x equals 21. I want to remove this 3 from the x, which means I need to use the multiplicative inverse to do so, because it is multiplied to x. So I multiply both sides by 1/3. When I do that, on the left-hand side, 1/3 times 3 is 1. Well, all we're left with is x. 21 times 1/3, well, that's 21 divided by 3. That becomes 7. So x equals 7.
I hope you found that video helpful. If you need any further help, just email me or call me on my Google Voice number. I hope you have a great day, and we'll see you next time.